to the video lecture series on Advanced Separation Process. My name is Chamin Pandya, Assistant Professor in LJ Institute of Engineering and Technology. So let's continue with the chapter number 1. In this lecture, we'll discuss about drawback of conventional process, need of advanced separation process and major area of application for advanced separation process such as chemical industry, pharmaceutical industry, food and dairy industry. So let's first talk about drawback of conventional process and need of advanced separation process. Existing non-membrane based equilibrium driven separation technology such as adsorption, absorption, extraction, distillation and stripping may have significant difficulty such as emulsification, foaming, entrainment, weeping, then lack of flexibility such as flooding, loading and need for density difference. Then other difficulty such as a slower rate, lack of modularity and need for large space. These difficulties are overcome by the advanced separation process. So let's first discuss about how the liquid-liquid extraction can replace by supercritical extraction. Liquid-liquid extraction used when simple distillation fails. To understand liquid-liquid extraction, let's consider there is a mixture of component A plus component B. Now if we want to separate this mixture, we have to use one solvent which is a component C. Now if we are going to add this component C in this mixture, this solvent either soluble with component A or component B. Let's suppose this solvent is a soluble with this component A. So it's make mixture of A plus C and we can separate component B. Now if we want to separate this both component or this mixture, we have to use distillation. So there is a requirement of one additional distillation column in liquid-liquid extraction. So in liquid-liquid extraction, require one additional distillation column that can be replaced by or that can be removed by using supercritical extraction. If we are going to use supercritical extraction instead of liquid-liquid extraction, we can remove this additional column. So it is beneficial in a point of view of the fixed capital investment and operating cost. So using supercritical extraction, we can replace liquid-liquid extraction process. Now let's talk about the other separation process which is a distillation. We can replace distillation or can say that simple distillation with reactive distillation. In general, in chemical industry, after the reaction, the distillation process is used to separate the unreacted reactant and product or byproduct. So if we want to do this both things in one column, we can use reactive distillation column in which reaction and separation both occurs in one vessel, where in a simple distillation reaction and separation both occurs in different column. So we can minimize the cost of one vessel and also yield of the separation is also increased in reactive distillation. So in this reactive distillation, we can replace one additional cost of the reactor and we can also reduce the boiling duty and condensing duty compared to normal distillation column. So this is all about the reactive distillation column and how we can replace distillation with reactive distillation column and what are the benefit for that. So now let's discuss about next process which is a vacuum distillation. We can replace vacuum distillation with short path distillation technique. We can reduce the path of distillate to the condenser in short path distillation. We can arrange the condenser or can say that internal condenser in distillation column. So we are going to sort the path of distillate from the column to the condenser. If we are going to reduce this path, it is a beneficial for the thermal degradable product. So if we are going to do vacuum distillation for thermal sensitive product, there is a chance of thermal degradation in vacuum distillation due to this path. This path can be solved using the short path distillation because we are going to provide internal condenser in distillation column. So there is a less chance of thermal degradation for the thermal sensitive product. So we can easily replace vacuum distillation by short path distillation, and it give efficient product or efficient work compared to the vacuum distillation column. Now let's talk about one another technology, which is a cryogenic distillation, which is replaced by the pressure swing adsorption. Cryogenic distillation used for the separation of gas, in which we are going to do distillation by reducing the temperature. This process quite costly compared to the pressure swing adsorption. In cryogenic distillation, we have to use compressor, which make fixed cost as well as energy cost higher compared to the pressure swing adsorption. And in pressure swing adsorption, we are getting purity comparatively high than the cryogenic distillation. So pressure swing adsorption technique that can be replaced, or can say that cryogenic distillation technique that can be replaced by the pressure swing adsorption. Now let's talk about the next technique, which is a azeotropic distillation, which replaced by the pressure swing distillation. When the boiling point of two component is near about, let's consider there is a two component. There is component A, which boiling point is a 100 degrees Celsius, and there is a component 2, which boiling point is 110 degree Celsius. Now if we are going to do simple distillation to separate this both product, we cannot separate this product effectively. To separate this product, we have to use azeotropic distillation, in which we are going to add third component, which is known as a entrainer, which make minimum boiling point with one of these component, and we can separate other component. So in this technique, we have to add one another third component, which is a entrainer. But if we are going to use pressure swing distillation instead of the azeotropic distillation, we can replace this azeotropic distillation with pressure swing distillation. If we are going to apply the pressure, this azeotropic point is changed. If we provide further pressure, this azeotropic point shift, and we can easily separate this component A and B. So we can easily replace pressure swing distillation instead of azeotropic distillation. Now let's discuss about the next technique, which is a membrane separation process. We can replace many conventional technique with the membrane separation process, or we can also use hybrid technique with membrane separation process. For example, in ethanol water mixture, it forms azeotrope at 95.63% weight by weight of ethanol. So which means we cannot get pure amount of ethanol more than 95 or 96%. If we want to get pure amount of the ethanol, we have to use membrane separation process, or we can also use per evaporation technique with the combining with the distillation, where we can get 99.98% pure amount of ethanol. So this is all about the membrane separation process, or can say that drawback of conventional process and need of advanced separation process. Now let's discuss about major area of application of advanced separation process. Advanced separation process are no longer bound in domain of laboratory, but have found their way into the industry as a valuable separation process. This process have achieved impressive industrial importance for the resolution of aqueous liquid mixture, purification of chemical and biological product, wastewater treatment, hydrometallurgical processing, and many more. However, advanced separation technology or process is not for all recovery and separation problem, or it's not solution of all recovery and separation problem. In many cases, other processes are either more effective or less expensive, or both. But pressure driving membrane separation process such as a reverse osmosis, ultrafiltration, microfiltration have a certain specification, and in many cases it's overcome various difficulty compared to conventional process. So application of this membrane separation process are shown in this table. So mainly if we are going to talking about the chemical industry, advanced separation technique has the most important and practical useful modern separation technique in chemical industry. Some of major applications are production of processed water for the industrial use, wastewater treatment, desalting of food, acid and reactive dyes, concentration of all types of dyes. Beside conventional use, advanced separation technique establish potential of use in energy generation by proton exchange membrane, fuel cell, greenhouse gas separation, microelectronic and other cutting edge technology. Advanced separation technique is not limited to the only chemical industry. It also used for the pharmaceutical industry. In pharmaceutical industry, it used for the concentration and purification of soluble macromolecules such as a plasma, protein, vaccine, enzymes, and yeast. It's also used for the produced water as per the Indian standard, and it's also used for the endotoxic free water. So in pharmaceutical industry, we can also use the advanced separation process. In pharmaceutical and cosmetic manufacturing industry, membrane technology and advanced separation technology assume important in success of many new products and process. While traditional process has been changed over to membrane with cost saving and improved yield due to the macromolecule nature of most of biogreenery product among with the harvesting and the fermentation technology required. Advanced separation process are already playing a key role in this all process. Now let's talk about the food industry and dairy industry. How the advanced separation technique affect on food and dairy industry. The dairy industry is a potential large user of membrane in India. Through the application have been few, yet the potential is a very large and will provide energy saving, processing without phase change and higher recovery of quality product. Following are various membrane process used in milk process industry, such as a lactose and protein concentration, concentration of whole and skim milk, lactose and protein separation, gelatin concentration, and pepping enzyme concentration. So this is all about the application of advanced separation process. So in this lecture, talk about the drawback of conventional process and need of advanced separation process, how the liquid-liquid extraction separation process replaced by the supercritical extraction process, how the distillation can replace by the reactive distillation, how the vacuum distillation can replace by short part distillation, how we can replace the cryogenic distillation with the pressure swing adsorption, and how the pressure swing distillation beneficial compared to the azeotropic distillation. Then discuss about the drawback of other process and use of membrane separation process, various application of membrane separation process and advanced separation process in pharmaceutical industry, food and dairy industry, and chemical industry. So this is all about today's lecture. I am completing my lecture here. Thank you.